Oh hey lads, it's Nani here today, bringing you lot a lovely video. And today's video, we're going to take a look at ln to the power of 2 of x dx. What's that equal to? Right, before we jump into it, I want you lot to leave a like and subscribe. So let's get down to business. Right, so in order to solve this, you lot are going to need to use the integration by Paul's formula from integral calculus. We are then going to proceed in making a small little table. And in this table, we got to determine which is our u and dv variable according to this chart. This chart will help us determine which is going to be our u and dv respectively. Right, so we have ln² of x. That's a function being multiplied by an imaginary or an invisible 1 basically rather. So therefore the 1 is going to be our polynomial, and our logarithmic function in this case is going to be ln² of 2. So log finds itself just above polynomial. So therefore, u will be equal to ln² of x, and your dv is going to be a polynomial, in this case, just 1. So let's take a derivative on the left-hand side. So the derivative of ln² of x is given by this. You're basically doing a chain rule. So it's going to be given as 2 ln of x multiplied 1 over x dx. And on the right hand side, you are going to just have to take an integral basically. And when you integrate 1, you're just going to have x. So we're going to take these variables and substitute them inside the integration by Paul's formula. So let's do that straight away. So once you have done that, we have this integral which we are going to simplify by cancelling out the x's, because they show up in the numerator and in the denominator. So we can write the integral as shown on your screen. And we basically have the integral of ln x now, dx. And this here is going to call for another integration by Paul's. And therefore, we got to make our own little table again, where we got to determine which is our u and dv variable. And in this case, we have 1 being multiplied, in a visible 1 being multiplied with ln of x. Therefore, you have a polynomial and you have a logarithmic function. A logarithmic function in terms of ln of x will be our u variable. Now, dv will be just equal to 1. And the same idea here applies. We are going to take a derivative on these two left boxes over here, which is going to be 1 divided by x dx, and on the right hand side we are going to integrate, and we're going to have v is equal to x. We are then going to substitute this into the integration by Paul's formula as shown, and we are going to simplify. The x's are going to cancel out here basically, and this here is essentially the answer to this section of the integral, which is x ln of x minus 1. We are going to take the result of this and substitute it inside this equation, and then we got the final answer. So this is what the integral of ln² of x is equal to. So if you lot enjoyed this video, please drop a like and subscribe, and I'll see you lot later.